Hello, this is Mrs. Thompson. Welcome. And today we will be looking at the law of sines. Here are our objectives. The law of sines tell us that inside a triangle, the ratio of the sine of an angle in the triangle to its opposite side is equal to the sine of any other angle in the triangle to its opposite side. So, as you can see, capital A, B, and C represent the measures of angles inside the triangle, and lowercase a, B, and C represents the length of the sides opposite the corresponding angles. You must have the following three things or pieces of information to use the law of sines. 1. The measure of an angle must be known. 2. The length of the side opposite the known angle measurement must be known. And lastly, at least one more side or one more angle must be known. Examples of determining if the law of sines can be used to solve an oblique triangle. Looking at problem B, we have the measure of angle C given 50 degrees and the length of the opposite side, side C. We also have an additional measurement. So yes, the law of sines can be used to solve triangle B. Looking at problem C, once again we have the measure of an angle, angle B this time, and the length of its corresponding opposite side, side B. In addition, we have one more fact, so yes, the law of sines can be used to solve triangle C. If we look at problem A, we see that we do not have the measure of an angle and the length of its opposite side. We do not have the measure of any angle, so we do not have that pair. Angle measurement with the measure of its opposite side for problem A. Therefore, the law of sines cannot be used to solve problem A. In the next section, we will cover a method for solving a problem such as problem A. Looking at an example of solving a triangle. First, let's talk about what it means to solve a triangle. To solve a triangle means when you finish the problem, you will know the measure of all three angles and the length of all three sides. We never make things harder than necessary with math. So, whenever you are given the measure of two angles, we go back to our elementary school days and just remember that all three angles in a triangle must total 180 degrees. So, for this problem, 99 degrees plus 50 degrees plus 31 degrees equals 180 degrees. Therefore, the missing angle measurement, the measure of angle B, must be 31 degrees. Now let's move on to finding the length of side A and the length of side B. We have two missing pieces of information, so we will have or need two separate proportions to solve one for each missing piece of information. Well, we can only have one unknown in our proportion because it's an equation. We can have only one unknown. So first we need an angle and corresponding side where we know the measure of both, and that would be angle C and side C. So we go ahead and use that. We substitute that in. And then on the other side of the equation, we need one of our missing pieces of information. I'll just go with A. and its corresponding angle measurement, plugging it in, which will give us the sine of 99. Proportions, if you think way back, they can be solved easily by cross multiplying and then dividing by whatever is multiplied by the variable. So sine of 99 times 14, cross multiplying and dividing that by the sine of 50 to get the length of side A. The symbol is changed to an approximate symbol because we are rounding. The same procedure is used to find the length of side B. Here is another problem. It is work like the previous problem. I suggest that you pause, work the problem on your own, and then check your work. This slide points out some additional important information. First, if the sine of an angle is greater than 1, then that angle is not part of a triangle. It's letting you know you do not have a triangle. And we will look at an example of this. Also, when the sine of an angle is greater than 0 but less than 1, sometimes you can have not one, but two triangles. And we'll also look further into this. So, once again, we're given a triangle to solve. We need a pair where we know the measure of the angle and the measure of the opposite side. That would be angle C and side C. So we go ahead and plug in the information for C in our law of sines. Finding our first piece of missing information, the measure of angle A. So plug it in the ratio that contains the measure of angle A, sine A, over the length of side A, which is 20. We're ready to solve for A. So cross multiplying 20 times the sine of 50 and then dividing by 10. We find that the sine of A, after plugging this in your calculator and rounding to one place behind the decimal, is equal to approximately 1.5. While 1.5 is greater than 1, so that means that though we have three angles and three sides, this is not a triangle. So we're finished. We cannot solve this triangle because it does not exist. In other words, the measures of all three triangles would be greater than 180. It just would not be a triangle because that sine, again, is greater than 1. Solving another triangle. As always, the given information is in the box. So the pair that we know both measures of, the measure of angle A is 40, the measure of side A is 30. Of course, we plug that right in. Moving on to find the measure of angle B. We don't know it, so we leave that capital letter B, sine B here. And of course, the value for lowercase b, 20, that length going in the denominator. Cross multiplying and dividing, we find that the sine of b is approximately equal to 0.4285 when round. Well, if we take the inverse sine, we find that, we know that there are two angles that has this sine value, 25 and 4/10 degrees, or 180 degrees minus 25 and 4/10 degrees. In other words, 154 and 6/10 degrees also has this sine. So we have two angles. That's an answer. This time, if we take the larger amount, 154 and 6/10 degrees, added to 40 degrees, we see that we don't have any amount remaining to make up the measure of angle C without going over 180 degrees. So this is just a one triangle situation because the other angle is too large. It would cause all three again to total over 180. So you just finish solving the problem. The measure of angle B would just be 25 and 4/10. And then you would proceed as usual to find your other measure. You can see the remainder of the problem here. This problem is similar to the last problem. We are again solving a triangle, finding the measures of all the angles and all the sides, or all the unknown measures of angles and sides. Given information here in the box. We know the measure of angle A and the length of side A. That's a pair. All we need to get started. So we plug that right in. For the measure of angle A, we have plugging in 35. Length of side A 60. Moving on to find the measure of angle B. We don't know it, so we just copy B, sine of B. But for the length of side B, we replace lowercase b with 80. Cross multiplying sine 35 times 80 and dividing that by 60. You can plug all this right in your scientific or graphing calculator. When you round to 4 places behind the decimal, you will find that the sine of angle B is approximately equal to 0.7648. Take the inverse sine of that to find that the measure of angle B is 49 and 9/10, or 180 degrees minus 49 and 9/10, which is 130.1 degrees. This time, both angle measurements, 49 and 9/10, when added to 35, you still have some amount left. That would be the measure of angle C, and that means the amount left before you exceed 180 degrees. And the same is true when you plug in the other value for angle B. 130 and 1/10 plus 35 still gives a remaining amount for angle C. So this time you will have two triangles. And then you would just complete the problem. Of course, since you have two triangles, you would have two values for angle C. You would use the fact that all three angles total 180 to find that as usual. And likewise, you would have two values for the length of side C. Concluding with an application problem. Martin wants to measure the distance across a river. He has made a sketch. Find the distance across the river, A. So as you can see from the diagram, the length of side A is the distance across the river. Well, if we're trying to find the length of side A, the distance across the river, that must be included in our equation. So plugging in for A, or in other words, keeping A, that's what we're trying to find, it must be in our equation, and plugging in for angle A. Angle A, the angle opposite side A would be 23 degrees, making our first fraction, the left-hand side of our equation, lowercase a over the sine of 23 degrees. Now getting the other side of our equation, the other side just needs to be an angle measurement, the length of a side and an angle measurement where we know both values. So side C, if we notice it has a measure of 348 feet. And the side opposite side C, the angle opposite side C, has a measure of 31 degrees. So we know the measure of angle C and the length of side C. So we have the measure of that pair. We can plug those in, cross multiply, and divide as usual. We find that the measure of side A the length, the distance across the river when round to the nearest